Hello everyone, welcome to eTutorPool.com. This video is about limits. Limits are very important in the study of calculus. We will see limits in a variety of places. In this video, we will discuss just what a limit tells us about a function. Okay, so let's start. So limits is all about approaching. Sometimes you cannot work something out directly. What you can see what it should be as you get closer and closer. We will understand this statement using a function. Okay, suppose we have a function fx equal to x square minus 1 upon x minus 1. Okay, what if I ask what would be the value of fx at x equal to 1? Let's see. At x equal to 1, substitute x equal to 1 in the fx. Okay, so f1 is equal to 1 minus 1 upon 1 minus 1. So this is 0 by 0. Now this is 0 by 0 is difficult. We don't really know what is the value of 0 by 0. This is a indeterminate form. 0 by 0 indeterminate form. If you see, there are 7 types of indeterminate form. Let me write it down, all 7 types of indeterminate form. Zero by zero, we just saw that 0 by 0. Okay, infinite upon infinite, 0 into infinite, infinite minus infinite, 0 to the power 0, 1 to the power infinite, and infinite to the power 0. Okay, so these are the 7 types of indeterminate form. Whenever you will get these indeterminate form, when you substitute a value in a function, you won't be able to know what would be the value of that function at that value. We just saw that at x equal to 1 we are getting 0 by 0 indeterminate form. We don't know what is 0 by 0. Okay, so we can work this out in using a different approach. Okay, so we are going to use a different approach. Okay, different approach. Okay, so in the statement, I said that sometimes we cannot work something out directly. Okay, but we can see what it should be as we get closer and closer. Okay, so closer and closer at x equal to 1 on a number line. Suppose this is a number line, this is 0, this is minus 1, and this is minus 2, and it goes on. Okay, and this is 1, this is 2, and it goes on. Okay, suppose we are going to get closer and closer at x equal to 1. We can get close at x equal to 1 from two sides. Okay, we can go from left, close, and we can go from right, closer and closer. This is 0 0.5, this is 0.25. Okay, this is 1.25, this is 1.5. Okay, So we are going to make a table. Okay, we are going to make a table for x and fx. Suppose you put a value x equal to 0.5. When you substitute 0.5 in fx, so you will get 1.50000. Okay, and now at first we are going from left to 1. Okay, 0.5. Now we are going to substitute 0.9. Okay, when you substitute 0.9 in the given function, you will get 1.9000. Okay, as you get closer and closer, next you substitute 0.99, you will get 1.999. As we get closer and closer to 1, as we are going to get from left, we are going to we are getting closer and closer to 1. You can see we at first we are getting 1.5, then 1.9, 1.999. You can see it's getting close and close to 2. Okay, so from now we can from this we can see that as as x gets close to 1, then fx, our function, which is x square minus 1 upon x minus 1, gets close to 2. Okay, in a mathematical term we write uh, x gets close to 1. X is approaching to 1. X is approaching to 1, then fx is approaching towards 2. Okay, so now we are faced with an interesting situation here. When x equal to 1, when we are substituting x equal to 1, we don't know the answer because we are getting 0 by 0. This is a indeterminate form. Okay, what when you get closer and closer to 1, the value of the function is getting closer and closer to 2. Okay, we want to give the answer to but cannot. So instead, mathematically, we can say that we mathematically we can use a special word here, which is limit. The special word is limit. Limit. So we how we are going to write this? The limit of x square minus 1 upon x minus 1 as x approaches 1 is 2. The limit of this function as x approaches to 1 is 2. Okay, see in this table in this table we went from 0.5 to 1. We went from left to 1. Now in the next table what we are going to do, we are going to go from right to 1. Okay, let's make another table. this is x, this is fx. Fx is equal to x square minus 1 upon x minus 1. Now we are going from right. This is 0, this is x, this is y, this is 1, this is 0 0.5, this is 1.5. Okay, now we are going from right, closer and closer to 1 from right. Okay, now at first we are substitute as x equal to 1.5. When you substitute x equal to 1.5 in the given function, you will get 2.5. Next, now get more closer. Suppose here is 1.1. Okay, substitute 1.1, you will get 2.1. Now we are going more and more closer, 1.01, more closer. As you get closer and closer, so when you get 1.00001, you will get 2.0001. So as you can see, when we are going from right, closer and closer to 1, the value of function is going from 2.5, 2.1, closer and closer to 2. As x gets CLO close to 1 from right, then the value of the function gets close to 2. As x approaches towards 1, fx approaches towards 2. Now at first we saw the function at first we saw approach from left, and then we saw uh, then we saw uh, function gets closer and closer to 2 as we approach from the right. Okay, so how we are going to represent this in a mathematical form? In a mathematical form, we are going to represent limit as x close to 1, fx as x closer and closer to 1, but not x equal to 1, closer and closer to 1. Then this value is going to, when you go from left, x tends to 1 minus. This is at first we went from left, at first we went from left. So when we go from left, that is 1, the value of x is very and very less to 1, very and very close to 1, sorry, very and very close to 1, that is 1 minus. So we represent this by 1, and this is a small negative sign. Okay, represent the value of fx equal to the limiting value of fx as x gets closer and closer to 1 from left is 2, and from right, when the function when the value of x gets closer and closer to 1 from right. Now we are going from right, that is, the value of x is just very small is greater than 1, that is very small, that is 1. Or we are going to use generally use 1 plus this sign, we use 1 plus, we are going from right. So 1 plus the value of fx is the what would be the value of this limit would be 2, as we saw in the uh, previous table. All right. So we can say that the limiting value of fx at x equal to 1 is 2.